All right. So the previous example that we were looking at, that you watched the video for, we started with them giving us a factor of x minus 2 when we first looked to see, is that a factor of the polynomial? We found it was, and we were able to use that to move forward. But what if we know nothing about it? What if we don't know any of the zeros of the polynomial? How can we figure out where do we even start from? Well, that's what this next part, this last part of our video is going to be about. And so in this one, we're going to use what's called the rational zero theorem. And we have this ratio of P over Q, where P represents the factors of the constant coefficient. So the very end of the polynomial, the constant, we're going to look at the factors of that. That's going to be in our numerator. Q is an integer factor of the leading coefficient. So the first coefficient that we see, that we would go in the denominator, the factors of that one. So let's look at a specific example and see how we can use this P over Q to figure out what are all the possible zeros of the polynomial. These are, again, this is called the rational zero theorem. Whoops. I don't know if you can see that in yellow, but this is the rational zeros theorem. So this is going to give us any of the zeros, the x-intercepts, that could be written as a fraction. That's what a rational number is. A rational number can be written as a fraction. So that's important to understand, because some of our x-intercepts might be irrational, or might even have solutions that are non-real, which is going to be a future section. All right, so looking at this polynomial, we don't know anything about it, and we're going to try to factor and even graph this polynomial. So let's use the P's and the Q's. So remember, the P's are the factors of the constant at the very end. So we start with the end. I know that's contrary to the way that we think, but we're going to start with the factors of 8. Factors of 8, now we have to include positive and negative ones. So looking for all the numbers that divide evenly into 8. So 1 divides evenly into 8. 2 divides evenly into 8. Whoops, 4, that's a plus. 4 goes into 8, and 8, whoops, forgot my plus or minus. 8 also goes into 8, so we plus or minus each of these. Positive negative 1, positive negative 2, positive negative 4, positive negative 8. The reason why we need both the positive and the negative is because negative 8 times negative 8 is 8, just like positive 1 times positive 8 would be 8. So we need to include all the potential factors. Okay, now we're going to do the factors of the Q. Q is the leading constant. Okay, so the leading term, the leading coefficient, the coefficient that's attached to that leading term, or part of the leading term. So we're just going to be looking at 2, so plus or minus 1, plus or minus 2. All right, so here's how we're going to list all the possible zeros. You can do it whichever way you want, but personally I like doing it this way, where I'm going to start with 1 in the numerator. Well, actually, no. We're going to start with 1 in the denominator. I think that's going to be easier. So we're going to start with 1 in the denominator. So we could have plus or minus 1 over 1. We could have plus or minus 2 over 1, which would just be 2. We could have plus or minus 4 over 1. Or we could have plus or minus 8 over 1. Okay, so all of these we're doing, again, P over Q. So all of these would be potentially our numerators in purple, and our denominator would be 1, or plus or minus 1 in our denominator. Okay, so now we've just done all the possibilities where we would have 1 in the denominator. Now we're going to do all the possibilities with 2 in the denominator. So we're going to have all of these over 2. Now we are going to simplify them, and if we have one already listed, we're not going to list it again. So one of them would be plus or minus 1 over 2, which would be 1/2. Now the next one would be 2 over 2. 2 divided by 2 is 1. We already have that listed here, so we don't need to list it again. So we're going to skip. We're done with 2. Next, we'll go to 4 over 2. 4 divided by 2 is the same as 2, so we don't need to list that one again. And 8 divided by 2 is the same as 4. We don't need to list that one again. So these are all the possible rational roots, or rational zeros for the polynomial. The possible zeros is step 1. So let's go to step 2. Step 2 is we're going to list, so we're going to test for zeros using the remainder theorem. Technically, what that means is we need to test every single one of these, positive 1, negative 1, positive 2, negative 2. So that would be a total of 10 numbers, because we have to include not just the 5 that we see, but the positive and negative each of those. So that means we'd have to test 10 numbers by plugging them in here for x, okay, which would be a real pain to have to do. So I'm going to make this a little simpler for us. we are going to jump and we are going to do I'm going to just pause this and I'm going to bring up our graphing calculator. Okay, so get out your graphing calculators. That's going to be the next thing that we're going to do, is we're going to use that to help us work through this, and I'll explain why. Once you get your graphing calculator up and running, hit the y equals button, and I want you to type in the polynomial that we're working with. I already have it punched in my screen here. By the way, a couple of reminders, the x value is right next to alpha, use where it says x, t, theta, and n. We're going to use that for our x. To do an exponent of 4, we have to use a caret button, which is underneath the clear button. That'll type something in as an exponent. I'm just going to show you down here. There we go. I'm going to go to a different spot here. So if I wanted to do x to the 5th, I'd do x, do the caret button, and then type in 5. But notice everything that I type after that will be up in the air with the exponent. So we have to do the right arrow on your keypad here. So do the right arrow to move the cursor back down. So in that way, when you type, it's not going to be as an exponent. Okay, so I want you guys to go ahead and type this in. So you might have to pause the video so you're ready to go to the next step. All right, so now we're going to go to our graph. Now, it could be that our graph, we may not be able to see a good shape of the graph, but let's see. All right, so I can see most of everything that I need. If you're ever wondering how to change the window settings, I'm going to cut off what I don't need. So I don't need all these values up here on the x-axis or down here on the negative x-axis. I need to go higher on the y to kind of see where this curve is, and I need to go way lower to see where the bottom curve is. So let's see what I could change the window settings to be. So right now the x minimum is at -10. Let's change that. So use the negative button, not the minus button. Let's change that to be -4. And let's go ahead and change the x maximum to be +4, just be a little symmetric. And the y minimum, we need to go way lower, remember, on the y-axis. Let's try negative, what do you think, -50? Is that going to be too big? I don't know. The y maximum, we need to go a little higher on that, so I'm going to go up to 20 on the y-axis. Let's see how that looks now. All right, so now I can see much more. Might want to move it over a little bit more, so let's maybe do that. So on the x maximum, let's go up to 6. And on the y scale, instead of counting by 1s, that looks so weird, I'm going to count by 5s. So my y scale will be 5. So if you need to pause this, be able to see what the window settings are again. If you're ever wondering, you just have to play around with it and try to get to a point where your graph looks nice, like this one. All right, so these are our x-intercepts, 1, 2, 3, 4. So remember, the degree of this polynomial is 4, and we do, in fact, have 4 zeros. Now, some of those are going to be real, some of them are going to be non-real. Remember, I'm counting by 1s on the x-axis. So 1, 2, 3, 4. So this one looks like it goes through at 4, which we could test in a second. But then these do not intersect at integer points. Let's go back to our notes for a second. So the only one that we have that's not an integer is +1/2 or -1/2. So let's go back to our graphing screen. This looks like it's a little bit past 1, but that is not one of our possible rational zeros. It's a 0, but it's just not a rational number. So that tells me that that x-intercept can't be written as a fraction. This looks like it could be -1/2, and again, this would also be an irrational number, so we don't know that one. So we need to figure out if this is at -1/2 and see if this is 4. So here's how we're going to do that. So instead of testing all of them, we're just going to test the ones that we are considering being actual zeros, the 4 and -1/2. So let's start with the 4. So literally, we would just type that in exactly as we see it on our scientific calculator, because I'll tell you on the test, chances are we would give you a graph, kind of like the graphing screen that we were just looking at. And that's all we would give you, just the graph. And you'd have to look at that graph and determine which ones are potential x-intercepts and test them. And so we tested 4, and sure enough, you would get 0 as your answer. If I tested -1/2, I'll just tell you, if you type that in, whoops, you'll also get, escape out of there, you'll also end up getting 0 as your answer. Okay, you would just replace all of these with -1/2 and so on. When you do that, you also get 0. So that tells us that our two rational zeros are going to be 4 and negative 1/2. Those are the only two that are rational. The other two are irrational. So we're going to see how we can use this now to factor this more completely. So to do that, we're going to use synthetic division to find the remaining zeros. So again, we're using, 4 and negative 1/2. So we're going to start with one of them. I think the 4 would be easiest to start with. So we're going to start with the 4. So again, the 0 goes here. The coefficients, 4, 3, 2, 1, 0. I was just looking at the exponents. All of them are represented. So I'm just going to list the coefficients: 2, negative 7, negative 8, 14, and 8. So I'm just going to go through this quickly, bring down the 2. 4 times 2 is 8. Add those together, we get 1. 4 times 1 is 4. Add these together, negative 8 plus 4 is negative 4. Whoops. Multiply 4 times negative 4, I get negative 16. Add those together, I get negative 2. 4 times negative 2 is negative 8. Add those together, I get 0, which is what I was planning on. Since it was a 0, we should have a remainder of 0. So now here's the deal. We broke this down. You don't have to write this down right now. Okay, I'm just illustrating what we just did. So we found a new polynomial. So we know that x minus 4 times this polynomial would give us our original polynomial, the 2x to the 4th minus 7x cubed, and so on. But I want to see, what we just found, can that be factored any further? So here's how you're going to do that. We're going to write down those coefficients that we just came up with. So 2, 1, negative 4, negative 2, not the 0. And now I'm going to use the other 0 that I didn't use yet, negative 1/2. Now you might say, well, I haven't done one with a fraction yet. And you're right, we haven't. But it follows the same rules. Bring down the 2. What's half of 2? 1, but it'd be negative half of 2, so that'll be negative 1. Add those together, I get 0. Negative 1/2 times 0, well, that's 0, so that's easy. Negative 4 plus 0 would be negative 4. What's negative 1/2 times negative 4? Well, negative times a negative is a positive, and half of 4 is 2. Add those together, we get 0, which is what I was expecting to see. So what we found is that we have x minus 4 is 1, 0. We have x minus negative, or one factor. X minus negative 1/2 would be x plus 1/2 is another factor. And then I could put, remember, negative 4 would be a constant. This would be x. This would be x squared. So then we would have our other factor be 2x squared minus 4. So now we want to look, so that would be our final answer in factored form. All right, they didn't ask for this, but let's go ahead. Oh no, they did ask for it. We want to find the remaining zeros. Sorry, I knew there was something else that we were going to do. So we have this in factored form, so now we're going to find the remaining zeros. We already know the zeros from these two. So now I'm going to find the zeros from this one by setting it equal to 0 and solving it. So if I add 4 to both sides, I get 2x squared equals 4. Divide both sides by 2. I get x squared equals 2. And if I take the square root of both sides, remember I have two solutions, a positive and a negative square root of 2. So those are my other two irrational zeros. Remember, those were the two other x-intercepts that we saw that would not work in the rational root theorem. All right, so I know that was a lot, okay, but I want you to try this on your own. Now, you might not be able to get very far. Might even be able to just get through this, start with the P and Q, and if you need to, you might even need to start all over again and pause this video and go back to the beginning and see what you did, or look over your notes. But I want you to do your best on this next one, so start with the P's and Q's. Then graph it. Okay, once you graph it, I want you to see if you can figure out what the other rational zeros would be, if there are any, and then get that in factored form, and yeah, see if you can do that on your own. So go ahead, pause the video and see what you can do. All right, let's see how you did or how far you got. So the first step is to use the P over Q theorem. So remember, the P is the coefficients of the constant, which are the factors of the constant. Factors of 51 are 1 and 51 and 3 and 17. So if you listed them on order, it would be 1, 3, 17, and 51. Remember your plus and minus for each of them. Our Q would be the factors of the leading coefficient, which is just 5. So we have plus or minus 1 and plus or minus 5. So now we write all these as fractions. So if you had a hard time with that, let's just review. I like to start with having the 1 in the denominator. So I'm going to have each of those 1, 3, 17, and 51 all being in the numerator and 1 in the denominator. So we would start with these 1 plus 3, 17, and 51. And now let's go to the next denominator. Let's have 5 in the denominator. So now we would have 1 over 5, 1/5, 3 over 5, so 3/5, 17/5, and 51 divided by 5, 51/5. Okay, so those would be all of the potential rational roots. So I'll just be honest with you, you're going to have to know this on the test where we're going to ask you what are all the possible rational roots and list them all out. So even though not all of these will be actual zeros or roots of the polynomial, you need to know how to list them out. All right, so now we've got to figure out, well, which ones of those are the actual zeros? Now to do that, we would give you the graph. So technically, I would give you this on the test. So let me bring up the graphing calculator. And if you want to see what window setting I use, so I could see everything all nicely like this, again, I just had to play around with it until I got a nice looking graph. And so this, if you want to pause it, you can see what I got for my different values, or for my window settings, and then this is what the graph would look like. So it's pretty clear that it has a 0 at 1 and -4. And I don't know what this is. Now, even though on the next screen I'm going to tell you what it is, I'm going to show you, we're going to pretend we don't know what this one is because I want you to have the practice. But we'll say that it's pretty clear that 1 is a 0 and -3 is a 0. So ignore, ignore this one. Okay, so I want you to see how we could figure that out without even having to use a scientific calculator and plug this all in. We're just going to start with these actual zeros, the -3 and the 1. So it doesn't matter which one you start out with synthetic division. I started with the -3. And when I did that, using synthetic division, I got 5, -22, 17, and we got 0 here, which is what we wanted. So these coefficients, I rewrote, and then I used my other 0. So again, I don't know this one right now. All right, so I write down 5, -22, and 17, and use my other 0 of 1. And when I do that, I get 5 and 17. So that is a polynomial where this is my constant, and then I just put an x here. So that would give me my zeros, and my factors would be x plus 3, because one of the zeros was -3, so x minus, each of my zeros would be a factor, so x minus -3 would be x plus 3. X minus 1 would be another factor. And then we're left with this factor, 5x minus 17. So that would be our answer factored completely. And then if they asked me to find all the zeros, well, now I would list them out. So I'd set each of those factors equal to 0. I would get -3, +1. And if I set 5x minus 17 equal to 0, I would get 17/5, which, if you notice, was one of them that we had here. But I wanted to go through and make sure you had the practice of using synthetic division to get this in factored form. So hopefully that makes sense, and good luck now as you finish the rest of this assignment for lesson 2-4.